Today we are going to talk about how to control the non-data elements of a plot. Now in Python, we are going to talk about the theme layer. Theme layer allows you to control the non-data elements. Now we have the same similar option in Seaborn implementation as well. So when it comes to theme layer, basically theme layer allows you to get visually appealing plots. Now, if you go and check the default setting, by default, these plots made in Seaborn have a white background. You can see all these plots have a white background. But if you want to change the background so that it allows you to improve the visual representation, then you can select a built-in theme. So there are complete themes which controls all the non-data displays. And just like in our ggplot implementation, this Seaborn also provides several built-in themes that allows you to customize the appearance of your plot. So basically, as I explained earlier, they all control the non-data display. So these are some of the options that you have. I told you by default, the plots made in Seaborn have a white background, but if you want, you can change it to dark grid or white grid or dark white. This is the default setting and ticks. Let's see a few examples. So now if you want to change the background, so this is the only thing that you need to do before calling this Seaborn plot call, you can first set the theme. So here SNS, now this is inside this Seaborn package, there's a function called set theme, and then you can pass the preferred theme, style equal the preferred theme. And then after you set the theme, then you can just write down the code for the plot, Seaborn plot. And finally, you have to display the plot. So this is how you get in with the default setting. Now, once you set your theme to this dark green, it allows you to get your plot on this type of a panel. And another example, let's say if you want to get it into white grid, having a grid allows you to explore them very easily. For example, if you come to this one, now you have to think about this. Now, if you want to think about the values greater than 200, the penguins whose flipper length greater than 200, then you have to draw it. You have to think about a vertical line here. But if you have this type of a grid, that allows you to explore the data very easily. Now, when you set it to dark grid, you got it like this. If you just want to have it in a white background, you can set it to white and just pass your previous code. And now it allows me to get it on this type of a panel. And another example, part is, now let's say you just want to have them on a dark background, then you can set your style to dark. I told you by default, you get it in a white background. If you want to convert the background to a dark background, you just set it to style equal to dark. So likewise, you can change the background, and that will help you to get visually appealing plots. Okay, and then during Tianga's session, she explained how to, sometimes there are situations where you cannot have very large number of plots in a single document. For example, certain journals, they have their figure restrictions. Sometimes you are allowed to have a given number of figures. If you are going to exceed that one, sometimes you have to pay for that. So in such situations, how can if we can combine some plots together, and thereby if you can combine some plots together, then you can reduce total number of figures. And sometimes having all these plots together allows you to give a better story regarding the data. So now let's see, now in our patchwork, Tianga discussed a few extensions of ggplot2, and the patchwork, we use patchwork to combine multiple plots together. And in Python implementation also, we have an option to combine these multiple plots together. So this is how we can do it. So first you have to, now when it comes to Python, we don't have a separate library for that. This Seaborn library allows us to do that one. So it's not the Seaborn library, the matplotlib library allows us to do that one. So there are two ways of doing this. So first, let me explain the first method, and then I'll come to the improved version of that. So now if you want to, let's say you have these type of 3 plots, and now you want to put it into a single graph like this. Then what you need to do is, as the very first step, you have to first define your entire panel. It's like you take a paper. Let's say now you are going to create 3 plots on a single paper. So as the very first step, if you are going to do it manually, then what you need to do is first you need to get the paper for you to draw the 3 plots. So now this is like figure axis. Now this is like you set a paper for the entire visual representation. So here you pass it as figure axis, plot, and so here PLT, that's from Matplotlib, we have an option called subplot. And now there I'm going to define a 2x2 grid. That means 2 columns. I'm going to define a grid with 2 columns and 2 rows. Altogether, I have only 3 plots. And then I define the figure size like this. So now basically this allows me to define my plotting panel. After you define it, then you can draw the plots that you want to put together. So here this allows me to get the scatter plot. Yesterday we talked how to get a scatter plot like this. And then you can also define, now here, this is what we discussed yesterday. Basically, this part allows you to create a scatter plot. In addition to that, here you can pass the position for that scatter plot. Here now I'm going to draw a scatter plot for flipper length and body mass, and I want to place that at the first panel. So here I define AX equal to AXX. This is what we defined previously. This is 0, 0. Now, another thing that you need to understand when it comes to Python, here in Python, both list strings, they use zero-based indexing. In Python, it uses zero-based indexing. That is, index of the first element is always 0. Now, this is a little bit different R. For example, let me first explain this indexing, right? When it comes to Python, let me use an example. When it comes to Python, if you just define a vector, let's say here I define a vector with these 4 elements. This is how we can define a vector in Python. So my list equal to, within square brackets, you have apple, orange, banana, and mango. Now let me just run this one and show you. So basically this allows me to create a vector of character vector of 4 elements. And now if you go and check my list, so now the name of this vector is not my list, and you can extract elements of this vector by referring to its index. If you go and check my list 1, what you get is orange, not apple. Here, if you go and check my list 0, it gives you apple. So now, as I explained earlier, so this is because this Python is a zero-based index. Python uses a zero-based index. That is, the index of the first element is 0. But if you go and do the same thing in R, so this is how you can define, I hope you all can see my screen. So if you go and just run it, so this allows me to, this is how you can define a vector in R, right? I define the same vector. So if you go and check my list, here I have apple, orange, banana, mango, the same vector. So basically C stands for concatenate, then you pass all the elements within normal brackets. Now, if you do the same thing that you did in Python, and if you just run this one, mylist 0, if you run this one, you can see, mylist 0 returns you, let me run this one, mylist returns character 0. But if you go and check mylist 1, now it gives me an apple. So now when it comes to R, it's not 0-based indexing. It starts with 1. But in contrast, when it comes to Python, it uses 0-based indexing. So the indexing starts with 0. The index of the first element is 0. The reason for me to discuss that one here, because now once you come to this, you can see how I have defined the position. First, I define a grid with 4 plotting panels. I define a grid with 2 columns and 2 rows. Now I want to place my first scatter plot to this particular panel. So now the indexing, it uses 0 index-based indexing. So you refer to it as 0, 0. The first one refers to the row. The second one refers to the column. So 0, 0. Then I create my second plot, box plot, and axis 0, 1. So first row, 0 refers to the row, second one in the element refers to the column. So now this is my first column. This is my column 1, this is column 0. So I refer it here. And the next one is histogram. Again, you get it as we discussed previously. And finally, you explain the position. And now you can see we created our grid. We created a 2x2 grid. That means it allows us to put 4 plots. But in this visual representation, I only have 3 plots. So there's a place here. Now I don't have any other plot to put here. So what you need to do is you have to remove that one. So that's what I have done here. Remove empty subplot. This, I don't have anything to plot in this part. So you pass figure. This is delete axes. Delete axes. I don't have anything to put it here. So I just ask it to delete that one. And now you defined the layout. After you define it, then you pass PLT inside this matplotlib. You have tight layout. Once you pass it pass it through this one, it will put them together. And you can, once you combine them all, you can add a common title for all these plots here, figure, subtitle, penguin data analysis, and you can control the figure size and the position of the title. And finally, you have to use the plot show in order to get these outputs inside the Jupyter Notebook. I hope it is clear to you. Now, but before that, now let's first show you what happened if you just omit this one. That means we have created 2x2 layout and we have defined 3 plots and I ask you to put together. Now, if you run this one, now you can see here you get this extra plotting panel. But we don't have any plot to put there. That's why we have this part. We can ask it to remove that additional panel because we don't have anything to plot there. So now if you put figure, this is delete axes, then you have to define the position. And if you run it, here you get it in a nice layout. Sorry, you get it in a nice way. Okay, so that's one way to combine multiple plots together. Now the ideal situation in this situation is now I have defined 2x2 grid, 2 columns and 2 plots. If I have 4 plots, then you will get a very nice, very visually appealing plot. But here you can see it's better if you can use this space for this final plot. At the moment, I have a blank space there. And I have, if you can add one more plot, then you will see it as a complete plot. Or else if you can utilize this additional space for an existing plot, then again you will get it in a good, we will get a good visual representation. So let's see whether there is any other possibility for us to have these things together without wasting this type of, without having white spaces like this. So let me explain the second option. Now we can easily do, now it's better compared to this plot. If you can see compared to this plot, if you can get it in this way, then we haven't wasted any space. Now let's see how we can do that one. So I'm talking about the second option. So for this, now create the figure and grid layout. Now, previously we used this type of a subplot function available inside the matplotlib. There's another option for you to put the multiple plots together by using add grid specification. So let's see how we can do it using this option. So as the very first step, you have to define your plotting panel. Yeah, it's like you define your entire final paper that you are going to print all these plots. So here, this is the inside this matplotlib package. There is a function called figure. So plot figure, and here you define the figure dimensions. Create a new figure object with size 10 into 8 inches. And then I save it as fig, so that now define my final, that defines the final plotting panel. And once you define, it's like you take a piece of paper. And then now you have, then you try to allocate different areas for these multiple plots that you are going to have in a single figure. So the second step, basically divide your original paper into multiple components so that you can put your multiple figures into one single area. So we can easily do it, figure add grid specification. So here basically you add a grid specification. Now we all together, let me first define it as 2 by 2, just like I did it previously. And let me call it as GS. Then what we can do is, now we have defined different areas. We have allocated, we have separated our original paper into multiple areas. Now we are going to draw the individual plots. So here, again, now I have figure and subplot. Now this is my original paper figure. So I want to add the subplot. And then I can give the location, GS00. And then you draw this one. Now here, this basically you define the location. Let me call it as AX1. And then you pass that location to this scatter plot function code. And then you can actually do some, and then sometimes when you combine plots like this, it's better if you can give this type of a label to each of these subplot. You can easily do that one. X1 text. Here you can define the position. This allows me to define the position where you need to put this A. Whether you need to put it here or here or here, you can change the location. And then transform axis, font size, font weight. You can just define additional improvements for this letter A. Okay, so that basically allows me to get my first plot to this location. And you can do the same thing for the other two plots as well. Another thing is, now here, you can even change these legends and the title positions, legend title and the position. Here, X1 legend dot set title, you can give a proper title to this one. Here, this part, from this part, what I'm going to do is I'm going to adjust, this part allows me to adjust, change the legend position. So likewise, by having these additional options, you can get the full control of your final output. And this part basically allows me to create my second plot. So now I want to place it here, 0, 1. So a figure at subplot. Now I want to place it in this on this position, at this position. So here I put it as GS01. And that is my next, I call that new location as AX2. And here I give guidance to this SNS box plot. Here I specify the location. And for that plot, I want to give this label B. So here you can just give it as, you can give an additional label to that subplot. Okay, so now I first place my first plot here and the second plot here. Now I'm coming to my last plot, this one. With the previous option, we had it on this part, 1, 0 panel. But you can easily change it to this type of an appearance. Here, this is what you need to do. Now, if you want to use this entire space, then what you can do is here AX3, figure add subplot, GS. Now, here I told you this one refers to the row. The first part refers to the row. The second part refers to the column. Now, you can, by using a colon like this, you can ask them to select the entire row for the final plot, for that particular plot. So basically it says GS1, okay, it goes to the second row. And then the second one, I have given it as a colon. That means it asks, now I ask it to use the entire row. If you want to have it here, you need to give it as 1, 0. Or if you want to have it on this side, you can give it as 1, 1. But now if you want to use the entire row, just replace that second part from a colon. And then after that, now that is my new location. Here I pass the new location, and this line allows me to give a proper label to my subplot. And now that completes my third plot as well. And now I have defined all my plots. Now again, you pass it as figure type layout. Previously also I used that one, plot type layout. And again, now you can add a subplot, main title to this one. Here, fig subtitle allows you to control the caption of the entire plot. And finally, you have to print the final output using plot show. Okay, now it allows me to get this type of a good visual representation compared to your first one. Now you have organized these multiple panels in a single document without wasting any additional spaces. And another improvement that you can do is, instead of having a penguin, this legend here, you can just, by changing the position of the legend, you can just put it here and use the entire space. You can do some further improvements to this plot as well. Okay, that basically now that allows you to combine multiple plots and put them together, and using that in whole figure, you can support your story behind the data. Okay, so then the next thing that I'm going to do is the interactive data visualization. Any questions up to this? Okay. Now, when it comes to R, Priyanka introduced you to a package called Plotly. Under extensions, Priyanka introduced you to a package called Plotly. Now, even in Python, we have this package. We have a package called Plotly that support interactive data visualization. So in R, the Plotly, ggplotly option function is primarily used to convert the static ggplot to an object to an interactive Plotly plot. Now we have a similar option in Python implementation as well. So to create interactive plots in Python, you can use the Plotly Express module from Plotly package. Now, there are several other ways of getting these interactive plots. Here, I'm going to introduce you to one option. Okay. So this module, this Plotly module available in Python, provides a simplified interface for creating interactive data visualization. Basically, this interactive data visualization means now these plotting options allows you to engage with data using different devices. It can be a mouse, it can be a keyboard. Yeah, but you can also use some options, activity zooming, hovering, or you can just using different input devices, you can interact with the visual representation. That's what we call interactive data visualization. Now, the interactive data visualization allows you to engage with the entire visual representation and get additional information. And that will allow you to improve your understanding. So if you're working with Plotly Express, you can directly utilize its API to create interactive plots without relying on the Seaborn or its functionalities. Now, when it comes to R Plotly, Tianga showed you how to convert any static ggplot to an interactive plot using a single line. Plotly, you just have to pass your static plot to this Plotly ggplotly. Then it will convert into an interactive data visualization. But now here in this case, when it comes to Python implementation, you don't have to rely on the Seaborn. You can directly draw a interactive graphic using Plotly Express package function available in Plotly package. Okay, so let's see how to create interactive scatter plot for flipper length and body mass. So this is what you need to do is now here I'm going to use this express function inside the Plotly package. So import. Yesterday we talked about this syntax, what you actually mean by this. So basically there's a function called Plotly. There's an function called express inside the Plotly module. And then I first import that one, and here we just give it a nickname as px. And from thereafter, I can refer to this function using px. We discussed these things in detail during our yesterday's session. And now I have now access to this built-in function. So now you can directly create a interactive data visualization using this option. If you want to get a scatter plot, what you need to do is px scatter. Here, as the first element, you pass the name of the data set. You pass x, you map this variable to x-axis. You map this variable to y-axis. And I also want to color it using species variable. And this final output, I'm going to assign it to an object called scatterplot plotly. And then you can display this interactive data visualization just like the previous case, scatterplot plotly show. Now that allows me to get this interactive data visualization. So basically now you can get, for example, let's say this is an outline point. Now you want to do, if you have sometimes when you have outlines in your data set, sometimes you want to go and see, you would like to do some further investigations on those unusual behaviors. For example, now here, this one is a little bit far away compared to other. Maybe if you want, you can just go and check. What's this? This species are daily, and flipper length is this much, and body mass is this much. And you can get back to the original scale like this. And here you can see, now most of these, let me get this one. So the same visual representation, right? If you just think about this one, now you can see when it comes to Gen 2, most of their flipper lengths are about 205. And when it comes to this chim strap, you can see their flipper lens are very little bit smaller compared to these Ginto species. But here you can see one outline point compared to all the other penguins inside this data set. This one is a little bit unusual. Now, if you want, you can go and check. You can go and do further investigations related to this. You can zoom in, and here I have this point, species chin strap, and here flipper length and body mass. Okay, so now it allows me to do further investigations. Interactive plots allows you to engage with data by zooming, hovering, or choosing variables to display. Then it allows you to get a better understanding about the dataset. Here's another example. So I'm again going to use the Plotly implementation. So if you want to get this type of a data visualization, so here now again you can see, if you come, let me first explain the visual representation. So here I have drawn a scatter plot between flipper length and body mass. And then here you can see the regression lines for these subsets. In addition to that, I would like to investigate the univariate distributions. This now allows me to see the distribution of the flipper lengths for each of these categories, Adderley and Gentoo and Chimstrap. And now if you come to this box plot, now if you just set your cursor there, you can see it gives you all the important information, the lower limit, the upper limit, and then you have the Q1, Q2, Q3. And then when it comes to this one, this is we call a violin plot. On this side, I ask it to give a violin plot. And if you can see what are the maximum values, what are the minimum values, what is Q1, Q2, likewise, you can get a better understanding about these things. So now let's go and see how you can create this type of a plot. So here, first PX, I'm going to create a scatter plot. Then first you need to define your data set. So I'm going to do this for the penguins data set. Then you do the mapping, this variable for x-axis and this variable for y-axis. And I want to assign color each of these points according to the species. So you have color species. And I would like to have few other additional. So basically that allows me to get my main scatter plot. In addition to that, I would like to explore the distribution of these individual variable subsets. We have univariate distributions of these subsets. So marginal y, I request it to give me a violin plot. Here marginal x, I want to add a box plot on axis margin. And then I would like to see, for these scatter plots, I would like to incorporate a regression line. So you can easily do it using trend line or least squares. And then template sample white. Use a simple white plot template. So simple white. And then you can also do some, you can also control some other aspects, customize the layout of the plot. You can, now this, I basically define my figure layout and I assign that to an object called fig. And then if you want to do further customization, you can update this layout. So here I give it a proper x-axis title and y-axis title. And finally, I requested it to display the final output. Now you can see, you can do lots of further investigations with these interactive visualizations, you can do many further you can do a proper further investigation with this, investigation of this data. Okay, so that's basically how to get interactive data visualization using Python. Okay, I think that's basically, those are the things that I wanted to discuss. So now you learn how to, so basically in this session, if I just summarize what we did during this data visualization with Python session. So when it comes to data visualize, so basically I explained that there are multiple graphical options in Python, but we selected Zborn due to several reasons. And then when it comes to Zborn, there are 5 basic steps. First, you need to prepare your data. You need to load your data to a Python environment. Then you can control the figure aesthetics. Then you can plug the Zborn, and you can also do the further customizations. And finally, you need to show your plot. And then first we talk about the controlling of data elements of a given graphical representation. And on the themes, we talk about how to control the non-data elements of a graphical representation. And finally, we discuss some extensions of this. One thing that we discuss is how to concatenate multiple plots to a single graph. I explained 2 options for that. This will be very useful for your reports, for your publications, for your thesis and presentations. And then we also talk about how to get interactive data visualization using Python. And there I introduce you to a different library called Plotly. Plotly allows you to directly get these without using Zborn. It allows you to directly utilize its own API to create interactive plots. Okay, so those are the things that we discuss under this session, data visualization with Python.